An EFI, or electronic fuel injection, engine test rig is a controlled environment. It allows technicians and engineers to run and assess petrol engines. These rigs are essential tools. They help us understand how EFI engines perform. The test rig replicates real-world driving conditions. This is done in a safe and controlled manner. Understanding each component of the test rig is crucial. We can then analyze the engine's behavior. We can also pinpoint any issues. Accurate fault diagnosis is fundamental for efficient repairs. It also ensures optimal engine performance. This essay will explore the key components of an EFI engine test rig. We will then delve into common electrical faults. We'll examine how to diagnose these faults. Finally, we will analyze engine performance parameters under full throttle. The Engine Control Unit, or ECU, is the brain of the EFI system. It receives data from various sensors. The ECU then adjusts the fuel injection and ignition timing. This ensures optimal engine performance and emissions control. The ECU is connected to a network of sensors. These sensors provide real-time data on factors like engine speed, air intake, and throttle position. Fuel injectors are responsible for delivering the precise amount of fuel to each cylinder. They are electronically controlled by the ECU. This precise fuel delivery is essential for efficient combustion. It also helps in reducing emissions. Sensors play a vital role in providing the ECU with the necessary data. The mass airflow, or MAF, sensor measures the amount of air entering the engine. The throttle position sensor, or TPS, relays the position of the throttle valve. The oxygen, or O2, sensor monitors the oxygen content in the exhaust gases. The fuel pump draws fuel from the tank and delivers it to the fuel injectors under pressure. Consistent fuel pressure is crucial for the proper operation of the fuel injectors. The throttle body is a butterfly valve. It regulates the amount of air entering the engine. The throttle position sensor is usually located on the throttle body. Electrical faults in EFI engines can be frustrating and challenging to diagnose. Faulty sensors are a common culprit. A malfunctioning MAF sensor, for instance, can send incorrect data to the ECU. This leads to an improper air-fuel mixture and poor engine performance. Wiring issues such as loose connections, damaged wires, or corroded terminals can disrupt the flow of electrical signals. This disrupts the communication between the ECU and other components. A thorough visual inspection of the wiring harness is crucial during diagnosis. ECU malfunctions, though less common, can occur due to various factors. These factors might be extreme temperatures, voltage spikes, or simply age. A faulty ECU can disrupt the entire engine management system. This may require reprogramming or replacement. Ignition system faults can also lead to engine performance issues. A failing ignition coil or worn-out spark plugs can cause misfires or a complete loss of spark. This results in poor combustion and reduced engine power. Section 4. Diagnosing electrical faults in EFI engines. Diagnosing electrical faults in EFI engines requires a systematic approach. Firstly, a thorough visual inspection is essential. Check for any loose connections, damaged wires, or corroded terminals. Pay close attention to the wiring harness and sensor connections. Diagnostic tools, such as an OBD2 scanner, are indispensable for retrieving fault codes stored in the ECU. These codes provide valuable clues about the nature of the fault. The scanner can also display live sensor data, aiding in pinpointing the root cause. Checking sensor outputs is crucial to ensure they are within the manufacturer's specifications. A multimeter can be used to measure voltage, resistance, and continuity. Compare the readings with the values provided in the service manual. When diagnosing ignition system faults, inspect the spark plugs for signs of wear, fouling, or damage. Check the ignition coils for cracks or signs of overheating. A spark tester can be used to verify the presence and strength of the spark. Section 5. Engine performance under full throttle. Understanding how engine performance parameters change under full throttle is crucial for engine tuning and diagnosis. As the engine speed, or RPM, increases, power and torque also increase, but only up to a certain point. This peak power and torque output occur at specific RPM ranges, which vary depending on the engine design. Air consumption increases proportionally with engine speed. The faster the engine spins, the more air it needs to draw in for combustion. This highlights the importance of a properly functioning air intake system and a clean air filter. Fuel consumption also rises with engine speed under full throttle. As more air is drawn into the cylinders, more fuel is injected to maintain the correct air-fuel ratio for combustion. This emphasizes the need for efficient fuel injectors and a properly functioning fuel system. By analyzing the engine's performance under full throttle, technicians can identify potential issues. For example, if power and torque are significantly lower than expected at a certain RPM range, it could indicate problems with the ignition system, fuel delivery, or air intake.